In terms of performance, what is the difference between a pipelined processor and a non-pipelined processor? Let's observe that. Let's say we have a program, and that program is having, suppose, the sequence of 3 instructions. So first, consider this table. Okay, consider this table as the pipeline. So each column represents a pipe. Okay, the pipeline entry, the column wise, and the rows represents the number of cycles taken by each instruction in the execution. So now let's assume you have a program. That program is having 3 instructions: instruction 1, instruction 2, and instruction 3. And suppose the processor is not having the pipeline, only the non-pipeline processor is, just assume. So to execute these 3 instructions through the instruction execution stages, the first instruction start executing by a processor. So the execution stages are instruction fetching stage. Then in the second cycle, the first instruction goes through the instruction decode stage. Then in the third cycle, the instruction will be executed. In the fourth cycle, the memory data may be read or write. And in the fifth cycle, the result will be write back into register file. So in non-pipelining, second instruction starts executing at 6th cycle, and it keep going on. In the 7th cycle, it goes to instruction decode stage. In the 8th cycle, the ALU will compute the performance. In the 9th cycle, the ALU output will either read or write into the memory. In the 10th cycle, the result will be write back into the register file. So then the third instruction in the non-pipelining processor starts executing at the 11th cycle. Then it goes through this 5-stage process to complete the execution. So to execute these 3 instructions, total how many cycles it took? Right. Now let's assume that the processor is enhanced with pipelining concept. That means introduce the interstage buffers. So the result of every stage will store into interstage buffer for utilizing further stages. So in the pipeline, the average cycles per instruction time means total cycles are 15 in non-pipelining, divided by how many instructions means 3. So the average cycles are taken as 5 cycles per instruction. If it is a pipeline, that means the processor can execute multiple instructions at different stages. Isn't it? Yeah. So see here the difference. First instruction enters into the pipe. Here assume every column is a pipe. Okay. So it is entered into the instruction fetching stage. So busy with program counter, instruction memory, and adder 1. Then in the second cycle, instruction 1 enters into instruction decode stage. That means the register file is busy in the read operation, whereas the instruction 1 functional units become idle. So the instruction 2 can be entered into the pipeline, that is in the instruction fetching stage. The instruction fetching stage. say, yeah, at the third cycle, instruction 1 enters into the execution stage. That means busy with ALU. So that means it is released the register file here. So instruction 2 can enter into the next stage, that is instruction decode stage. So instruction 2 busy with the register file. Then instruction 3 will be allowed inside the pipeline. That is the first stage, instruction fetching stage. So there are 3 instructions in the pipe. First instruction is utilizing the ALU. Second instruction utilizing the register file for reading the source operands. And first instruction is utilizing the instruction memory. Let me just write memory unit. From there the data is reading. So every instructions are executing in a different segment. So that's why there is an overlap in the execution, but they enter linearly into the pipeline. So Alan, it's like multiple people working on server problems at once instead of just one at a time. That's correct. Good observation. Kasmi, is this happening inside one pipeline or multiple? We are talking about one pipeline, one processor, one pipeline, Kasmi. So throughout all the discussion, further discussion also, assume that only one processor, one pipeline. Okay. Austin, Kasmi, good. Yeah. So now, is this make sense? Why the multiple processors helps to increase the performance? Got fantastic. Good. So now to talk this performance calculation in terms of the cycles, okay? So here you assume that without pipeline, the instruction takes, suppose, T time, the execution takes time T, suppose, then single instruction latency is every time, every instruction takes 5 cycles. So then what is the throughput means? It is 1 over T. One instruction is taking 5 cycles. Correct? So if there are 3 instructions means it is multiplying 3 instructions multiplied with 5 cycles. But if it is a pipeline 1, so what is happening in each cycle, having the task is divided into different stages. So the execution time of each stage, suppose, so that will be divided into the instructions. So that is equation wise, we can write it as with the non-pipeline, it is multiplied with number of instructions multiplied with their execution time. Like in our example, it is 15 for non-pipelining, without pipeline. With pipeline, number of stages are, suppose, 5 stages. In that case, each stage takes 1 cycle of time. So 5 stages divided by number of instructions. So the throughput is computed as if there are m instructions, that m instructions are multiplied with the number of stages. 3 instructions multiplied with their execution time over the number of stages, that gives the ideal cycles per instruction. So the ideal cycles per instruction pipeline is 1. The ideal cycles per instruction is 1.